Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will be discussing the problem asked in LeetCode Weekly Contest 424. Let's start with the first problem. So the first problem says that you are given an integer array nums, and so first you have to select two things. One is the current index and one is the direction. You have to choose the current index in such a way that the element present in that index is 0, and choose a direction. Then you start the processing. Now let's see what is the process. So if your current index is out of range, so either it's less than 0 or greater than or equal to 1, the process ends. Otherwise, you have to check if your current element is 0. If your current element is 0, then you have to keep on going in that direction. Let's say your current direction is left, so you have to keep on going in left, or if your current direction is right, you have to keep on going in right direction. And then the else if condition, if your current element is not 0, so this condition was when your current element was 0, and if it is non-zero, what you do, you decrement the value by 1 and then you reverse the order. If your current so you have to reverse the direction. If your current direction is left, it becomes right. If it's right, it becomes left, and then you like do the same process again and again, right? So until the process ends. So and at the end you have to find out the number of ways where you can select the current position and current direction in such a way that your all, like at the end of the process, your array becomes 0. It means that all the elements present in the array become 0. So you have to return the number of valid selection. So this is the test case, and there are two answers for this. So if you're starting at index 3 and if you choose the left direction like initially, then the array would become 0. And same if you, so yeah, and the second way is when you start at current index, same index 3, but if your current direction is right, then also the array becomes 0. So there are two ways. So actually this problem is a brute force problem. Just do whatever the problem says. Just write the code of the same problem statement. It would be accepted because n is 100, nums is 100. So even the brute force solution will also accept. Let's look at the code now. This is the code of the first problem. So I'm taking the size of array and a variable called ways, which actually tells you the number of ways you can start the process by picking current index and current directions to make all the numbers 0. Then what I'm doing the brute force way. I'm going through each possible index and each possible direction. So your 0 indicates left direction and 1 indicates right direction. Then I'm creating a new array each time because I'll be manipulating the same array. And then what I'm doing, I'm just doing whatever the asked in the problem. I can start the problem from those index whose number is 0, right? So I'm just checking if my current number is 0. If it's 0, let's start the process with current index and current direction, and let's see if we can make all the numbers present in the array 0. If it's possible to make, just increment your number of ways, right? Now let's see what this function does. So like if you look at the process step, it says if your current index is out of range, then your process ends. I'm just doing the same thing. If your current index is out of range, your process end, right? So once your process end, it means that you can't do any processing. So just check if all the numbers present in the array become 0. So I'm just checking if any of the number present in the array is non-zero, then return false. You cannot make all the numbers 0. If it's possible, return true. The second case says that if your current element is 0, you have to keep on going in the current direction, right? This is the statement. So what I'm doing, so I created a function called move, which will actually move your current index into current direction. So let's see what this move function does. So what it does, it takes current and direction. So if your direction is 0, if your direction is 0, it means that it's a left direction. So you keep on going in the left direction. So to go left, just decrement your current, right? And if your direction is right, you have to increment your current, and at the end return your current index. Then I just move into my current direction. Else condition, if your element is non-zero, then if you look at the third step of the process, it says that you have to decrement your value by 1. So I just decremented your current number by 1, then I flip the direction. So you have to reverse the direction. If your direction was left, it become right. If it was right, it become left. So I just jar it with 1. It will make 0 to 1 and 1 to 0. Then I'm just moving in my new current direction after flipping the direction. And then I'm checking if we can make the rest of the numbers in the array become 0. So I'm just calling this function again. So it's a recursion. I'm using recursion here, right? And yeah, so this is the like the solution of the first problem, which is, so I I just tried replicating the same thing which is asked in the problem, because your n is 100 and your max element is 100, so it would be accepted, right? Your complexity would be order of n into m into m, so 10 to the power 6, so it will be accepted. So now let's look at the second problem now. So this is the second problem asked in the contest. You are given an integer array nums and a query array, and in each query you will be given left index and right index. And now what you can do for each query, you can select a subset of indices within the range left to right, and you can decrement those selected indices by 1. And you have to make all the array elements to 0. So when all the elements in the array become 0, it called 0 array. So like the problem says, you have to check if it is possible to transform the given array into a 0 array after doing all processing, right, on the given query. And if it's not possible to make all the numbers in the array 0, just return false, right? So a subset is called select those some or none or all the indices in the given range, so it's called subset, right? So actually this problem, like the idea behind this problem is exactly same which I discussed in my one of the video in LeetCode bi-weekly contest 143. The concept is called prefix heading. So let's see how we can approach this problem using prefix heading. So I'll start with a null array. A null array is called those array whose all the elements are 0, right? I'll start with the null array. Now for each index I'll be trying to find what is the max possible decrement at index I. What is the max possible decrement at index I? Then at the end, what I'll be checking, I'll check if all the at each index, if your nums of I is less than or equals to, let's call it MPD array, is MPD at I for all I in the range 0 to and minus 1. If for all index in between 0 to n minus 1, if your nums of I is less than or equal to max possible decrement, then I can say I can make this array a 0 array. Right? So let's see how we can find this max possible decrement at any index I. I'll be using the prefix heading concept now. So we know we are given a query array. So for each query q of I, we are given left index and right index, right? I'll be using prefix heading concept. What I'll be doing, this is my array. I'll be incrementing at index li, because it says that you can increment a subset of indices between left to right. So I'll be incrementing my li and I'll be decrementing my ri plus 1 minus. So this is my first step. The second step is to do prefix sum. So this idea I have discussed in my LeetCode bi-weekly contest 143. The similar idea was used in one of the problem. I'll be using prefix sum. So once you do the prefix sum, your MPD array would be done. You would get the MPD array. Then what I'll be doing, I'll be checking for each index if my nums of I is less than or equal to MPD of I or not. Right. So let's see the code of this problem. So this is the code of problem. I'll be using the prefix heading concept. I get the size of the array. Then I created a new array, a null array initially, all the elements are 0. Then what I'm doing here, I just found the left index and right index for each query. I am incrementing the left index by 1 and I'm decrementing the r plus 1th index by 1. Then I'm doing the prefix sum concept. Then once you do the prefix sum, so prefix sum is equal to a of I is equal to plus equals to a of I minus 1. It's a prefix sum. Then once you do the prefix sum, your AI will tell you the max number you can decrement by doing any process, by choosing a subset of indices between L to Ri, right? The max possible decrement, MPD, you can get. Then what I'm doing, for each index, I'm just checking if like, so if you found any of the index whose given number is more than the max possible decrement, then it means that you cannot make it 0. So just return false. Otherwise return true. So at the end, it means that you can make the given array to a 0 array. So this is the code of the second problem. Now let's look at the third problem now. So this is the third problem asked in the contest. This problem is pretty much similar to the second problem, just a bit of different. Let's see what it says. It says you are given an array nums and a query array, and in each query will be given left index, right index, and a value. Now for each query you can do some action. So what you can exactly do, you can choose indexes in the range left to right in the given array, and you can decrement those by at most val. You can decrement either 0, 1, 2 up to val, and you can choose the index independently in each query. So in each query it's up to you which index you want to choose. You can choose the same index in multiple queries also. And so there is a concept called zero array, which means all the numbers in the array become 0. So what in this problem you have to return, you have to return the minimum possible non-negative integer k, such that after doing processing of the first k query, so you have to return the minimum value of k such that after doing the first like the processing of first k queries in the sequence, the array becomes 0, right? And if there is no possible k, just return -1. So let's say you are given 5 queries, and if after doing the first, like after processing first 2 queries, your array become a 0 array, then you just have to return 2. So let's see how we can approach this problem. So I'll be solving this problem using the prefix setting concept, which is already used in the second problem of today's contest. So what I'll do exactly, at each index, I'll try to find what is the max possible decrement which you can get, right? So let's say you have done the processing with the first k query, right? After doing processing with the first k query, let's say you found the MPD array, which will tell you the max possible decrement at any index. Then what I'll be doing, at the end, for each of the index in the range 0 to n-1, I'll be checking if my given number is less than or equal to max possible decrement. So this is the max possible decrement which you can make at any index, and if this condition holds true for all the index, it means that you can make the array 0, right? But here the thing is, so in the second problem it was just left and right, and it says you can decrement by at most 1, but here you are given a val of I. So but I'll be doing the same concept here. Instead of plus, I'll be doing a of at left index plus equals to val of I. Here it will be minus equals to val of I. So in the second problem it was just either increment it by 1 or decrement it by 1, but here since you are given a value, I'll be doing plus equals to val of I and minus equals to val of I. At the end, do a prefix sum. So once you do the prefix sum, you would get your MPD array, and then you can check for all the index in the range 0 to n-1 if your given number is less than or equal to MPD array or not, right? But so this is the whole idea what we will be doing exactly, but the twist is that you have to find out the mean value of k. You have to find out minimum value of k such that after doing processing with the first k element, your array become 0 array. So let's see how we can find the minimum value of k. So it's a binary search problem. Let's see. So let's say this is your given array. This is your given array. index with 0 and minus 1. Let's say I claim that my claim. What is my claim? My claim is that with the first k queries, this will be index k minus 1. With first k queries, if I can make the given array a 0 array, then I can also make the given array 0 array with k plus 1 element, or k plus 2, or k plus 3, right? So if it is possible to make the given array 0 array by processing the first k number of queries, then it is always possible to make the given array to a 0 array by processing k plus 1, k plus 2, k plus 3. So it's a monotonic behavior, right? So this problem can be solved using binary search. So once you find the k value, you just have to discard these number of queries, right? So what you are doing, you are given a search space left and right, you found the mid, then so let's say this is your k. If it is possible to k, just discard it. And one more thing, if it is not possible to make the given array to a 0 array by processing k number of queries, then it will never be possible with k minus 1 or k minus 2, right? So if it is possible, then the second half is discarded. If it is not possible, then the first half is discarded. So it's a standard binary search problem. Let's see how we can write code for it. So this is the code of the third problem. So first I check if the given array is already a 0 array. If it is already a 0 array, then you don't have to do any processing. So no processing is required, just return 0. Otherwise, I first found the size of the given array, size of the given query array. So I'm doing binary search here. This is my low. The minimum possible number of processing is 1 and the max number of processing is m, right? M is the number of queries. So I'm going with the index value. So this is my low index, this is my high index, and this is my answer. Then what I'm doing a binary search here. I found the mid. I created an MPD array. So MPD is basically your max possible decrement. Now from index 0 to mid, so I'm just check if by doing processing with 0 to mid you can make the given array 0 or not. So 0 to mid met, it means that after doing processing with the first mid plus 1 number of queries, can you make the array 0? So for each query we know that we are given left index, right index and a value. Then I'm doing the prefix setting concept. So here I'm incrementing the value at index L by val, and I'm decrementing at index R plus 1 by minus equals to L. I'm decrementing it by val. Then I'm doing a prefix sum. So once you do the prefix sum, you would get the MPD array, right? Then I'm just checking if I can make the given array 0 or not. So for each index, your MPD array of I, so at each index, if your max possible decrement is less than your given number, it means that you cannot make it 0. It has to be more than or equals to the given number. So if at any index your MPD is less than the given number, you cannot make it 0, right? So this is a 0 array initially, so I initialized it by 1, and if you find at any index your MPD is less than the given number, you cannot make it 0. And at the end you just check if it is possible to make the array 0. If it is possible, I already told, if it is possible, then there is no need to go on the right half, then there is no need to go for the bigger number of k. So your answer is mid plus 1. So mid plus 1 because you have to return the number of the value of k. So value of k would be index plus 1. The number of queries is mid plus 1 here for index 0 to mid. So answer is your mid plus 1, and now your high become mid minus 1 because you don't have to go to the right half. And else condition, if it's not possible, then it means that you cannot make the given array 0 by processing k minus 1, k minus 2. So go to the right half. So the first half is discarded. So in this case, your right half is discarded, and in this case, your left half is discarded. And at the end, return your answer. So the complexity for this case is order of n log n, right? So order of n for doing this processing, and log n is for doing binary search. So the overall complexity is n log n. Yeah, so this is the code of third problem. I'll be posting the solution of fourth problem pretty soon. I could not get the code of the fourth problem accepted during the contest. So once that is getting accepted, I'll post the solution of fourth problem as well. And yeah, if you find the video helpful, please like and subscribe to my channel. Thanks for watching. Have a nice day.